Hello everyone, LTS is back with another video for you guys. So today on the bench we have this HS-PC202 Mark III. This one was received from one of our customers. Device inside looks a bit dirty, and also from what I can see some parts are trying to just go out. All in all, it looks a bit worn. Let me check with the nail. But nothing crazy, actually. Okay, maybe let's do a little test. Let's remove this. By the way, this looks alright, just we have some dust inside. So this will be quite easily actually, we will be able to clean it. Okay, let's grab power supply. Let's see if we have some signs of life. No signs of life, at all. Absolutely. Okay, this is gonna be a bit more interesting, I think, because of that, and more complicated. Okay, that's not the right one. Where did I put that one? Right over here. Let's see if we have something with the battery cartridge. Okay. No life at all. Okay. As I said earlier, this will be, I think, a bit more interesting due to that. Okay, let's not waste any time and let's start to disassemble device from actually disassembling device. Nothing new right over here, yeah. Capacitors leaked. From what I can see, this DC jack looks actually terrible. But we have the belt, and belt is actually not very bad. Still have some elasticity, yeah. All right, let's remove the PCB then. Okay, first of all, we have some dust inside. Yeah, actually lots of dust. Maybe that would be wise to use some de-duster. Now it looks a bit better. Let's remove, let's actually not remove, but unsolder these wires. belt we will change because we have some indentation already in it. Okay, motor is very quiet. Let's use some oil a bit on that front bearing. Now we are super quiet. That's how it's supposed to be. Okay, we will clean all of those gears and so on. But right now let's just concentrate onto that PCB. So well, capacitors are leaked. Nothing new right over here. Okay, let's remove that potentiometer. Yeah, let's wipe a bit off because I see that we have some dirt and debris. I think that let's remove all of those capacitors at first, but before that, that would be very great to clean up that mess right over here. From the first glance, it doesn't look that all the capacitors are leaked, so that is very good thing. I think that we have massive leakage only from those two bad boys, and this one and some few others that are lower value. I think that they have not leaked already. But we will see. Yeah. No, we still don't get anything from that. Yeah, LED is not lighting up. That we will need to clean insides. What about now? No, still nothing. Okay, you know what? Let's check with the tester if we are getting something into the board. Actually. Yeah. We are getting nothing. Okay, we have something right over here. Okay, what about this guy? It is all right. I think that we have some problem with the DC jack. Yeah, because I see loads of corrosion right over here too. So let's remove these capacitors one by one. Okay, let's clean again those places. Okay, right now we will just prep capacitors, new ones, and we will start not soldering them, but a bit cleaning that PCB and those pads, and we will check also if we have all the tracks correctly, and we will check if all the tracks are actually all right and we do not have any damage on the VSM. Okay, let me prepare caps. We have prepared already capacitors. Right now let's just clean those pads if we still have those right over here, because it looks like they are just corroded off. Yeah. That would be great to remove that potentiometer. So let's remove it. From what I can see, we have loads of broken tracks and vias. Okay, let me do the investigation with tester, and I will start repairing all those tracks and vias. And I'll be back after finishing this very boring job. Alright, so I think that I have successfully repaired lots of broken vias and tracks. Right now, before everything else, I have tested DC jack, and it looks like it's working just perfectly fine. Right now, let's do the cleanup for potentiometer. Alright, so at this point I think let's start soldering all of the components back to the PCB. Well, customer asked also to upgrade output capacitors, so we've done just that. Okay, let's check quickly the switches. Okay. Now what? We can do little test. And no, this LED still doesn't light up. Still not lighting up. Okay, let me investigate and I'll be back. Okay guys, so I have found the issue. Right now, if we start, we see that LED lights up and also motor spins. Where I have found the issue, under this tantalum capacitor, there was also lots of corrosion, and I have forgot to clean it good. And track under it just was corroded off after running a wire from right over here to another side of this tantalum. Now everything looks to be in working order. Yeah. All right, so let's put this aside. Right now, let's concentrate into the tape transport. Yeah. So let's do, as always, as usual, let's remove tape door, and we'll start from right over here. What I also would like to do is to remove this upper cover. First things first, let's remove capstans. Okay, we still have that frosty coating, so we will. So I just don't need to resurface it. I think I will clean those buttons a bit later, or now. We can do it now also. Okay, I think that this is pretty much very clean. Alright. Motor spins very freely. That is always a good sign. Alright, let me grab the belt. Everything spins very, very freely. Let me see. What about torque? Very good. All right. Let me free up that azimuth screw. Okay, let's continue. Well, I have prepared for azimuth adjustment. This should, yeah, just go freely. And at this point, I think that, yeah, we can just start assembling it. This part and this we will put a bit later. Also tape door. Right now, let's just put PCB back and let's check. This head flex is the worst one to solder back. Let's put in some tape and let's see. Okay, so play. And we are totally quiet. Absolutely quiet. We have some issue. Let me check where it is. All right. After lots of time, I have finally found the issue. Or I should say, I think not the issue, but issues. Because there were quite a few of them. Well, first of all, there was no reaction to forward and rewind switch position. Every time you can hear just the forward direction and that's it. Another thing why we have not heard any sound is because Dolby ICs were not getting power. Under this capacitor there is some crack into other side, and basically we are not getting anything right there. Yeah. And there was also missing right channel under this capacitor. I have not noticed, but there was some cracks, and I have to use some wires, some tiny wires to connect it, and then finally it started to play in both channels. Okay, so right now we can finally put that cable back, and we will solder everything to its place. Normal tape, and will we get the sound? That is the question. Yeah, one direction, other. Cool. It is finally working. Right now what I'm gonna do, I'm gonna set azimuth, and after setting azimuth I'll be back with tape speed. Jesus Christ, this fell off some time ago. Tape speed, wow and flutter, and so on and so forth. But at first, let's do the azimuth. Till then. Alright, I have just set the azimuth. So let's fix this screw in place. Right. Right now we can assemble the device a bit more just for better convenience, you know. Dolby levels, maybe at first tape speed on one plotter. And let's see. Well, not the best one plotter. What about other direction? Another direction we are a bit better. Let me try one more thing and I'll be back. Alright, let's check right now. I have done some magic and let's see if it works. Okay, so this is forward direction. Look at that. Not bad at all, yeah? Rewind direction. Also quite a bit better. Quite a bit better. Of course we are in the specification because service manual asks for 0.48 WRMS in forward direction and 0.45, if I remember correctly, in the rewind direction, and we are in both directions about 0.22. Yeah. Dolby levels. Let's check those. Okay, and as for the Dolby levels, we have to get 100 plus minus 5, so I think that we will do 95 because this tape that I use is -4, no, -1 point, actually -0.6 or something like that. So we will do a bit lower. All right. Normal tape, Dolby off, start. Okay, so ground, right channel. Okay, we have quite a bit too much. Come on. Come on, just stay in right here. I'm going to adjust it a bit. Okay, so it's 95 and left one Also, let's do 95. Okay, so 95 and 95. Perfect. That's it with Dolby levels. So what's left? We have just assemble device, and then that's it. We will do some testing. But wow, this device was such a mess. I have not maybe seen so much problems with one device. Yeah. And I think that we have forgot one thing. And let's see. Well, just look at that. Look at the low end. Low end is very good because we have used those larger capacitors. Very nice, I would say. There is some degradation on left channel. Yeah, but all in all, it looks very good. This is normal, and other biases, those are just Dolby levels. So quite not bad actually, frequency response for this unit. If we would change the head to amorphous one, I think that it would perform much nicer on the top end. But anyway, this is also very good result. Okay, so let's do final test with other tape. I have just put in some old school mixes. Yeah. And it plays very clearly, even on chrome position, and it is also chrome tape, but very nice playback. Yeah. Fast forward and rewind, all the functions working just perfectly fine. So that we have successfully repaired to near out of the factory performance. Yeah. So that's it. I hope you liked the video. As always, please consider supporting my channel. Also, please like, share, and subscribe, and I will see you in the next one. Cheers. Magic.